Good evening, everyone. Am I audible? Good evening, Dr. Jini.
Good evening, ma'am.
Yeah. You can start the session. Okay.
So, ma'am, today what I will do means I will teach one basic how to.
Yeah. You teach the basic how to launch and how to create the workbench and everything. What are the boundary conditions, basics, hands-on activity, right?
Okay,
So yeah.
okay, ma'am. My screen is visible or not, ma'am?
Yeah, it's visible.
Okay. So, in last class also we discussed how to launch answers. So the better one is like if you want to do any sort of analysis, that means a structural or a CFD or some explicit dynamics or some rigid dynamics, whatever. The best way is to open workbench. So in search we can type workbench. You will get the icon. Click that. You will get a interface like this. So this will be your workbench. So in workbenches, so many things were there. In left hand side corner, top left hand side, you can see the toolbox. There you can see the analysis systems. There are different type of analysis is there. Under that, we can see the fluid flow, then this harmonic analysis, hydrodynamic, LS Dyna, model acoustic, motion, random vibration, rigid dynamics. These are the different type of analysis: static structural, steady state thermal, structural optimization. So these are the different kind of analysis which can be done through answers. So our major part as a aeronautical or mechanical engineers, we will stick on to static structural, static acoustic we will do, steady state thermal we will do, same way transient thermal, transient structural. Then suppose if you are designing some or want to do some analysis over a pump or a turbine or a compressor means, then we need to take this turbo machinery fluid flow. So for even for designing that one, again separate thing is there. And below that, this CF turbo, that one is like a add-on. So in that add-on, we can design our own for a commercial aircraft engine, how the axial flow compressors and turbines looks like. Similar way, we can design here. Then you can see the component systems. In component systems, again, so many subdivisions were there. In that, one is ACP post, ACP pre. That means composite. If you want to design some composite material, then you can design through this one. Blade gen is for designing the blades. Similar way, so many things were there. Fluent, separate fluent is there, separate geometry is there, ice pack analysis is there, APDL is there, meshing part is there, results. So I told while doing a CFD analysis, it is like pre-processing, solver, and post-processing. So for pre-processing, we will use geometry. So again, to start the process, either if you want, you can start with this one, fluid flow fluent. So here also you will get everything, or else, but better way is like don't do like this. Why? Because in answers sometimes some error will come. Sometimes some part will get stuck or some sort of error will come. If in that case, what we have to do means, uh, if error is coming means, if you are using this module, fluid flow module, suppose any one part if error is there means whole thing we need to delete. No other way. But if you use this like separate geometry, if you are keeping, and separate meshing you can keep, and it means straight away you can delete that part and you can restore the remaining things. Otherwise that cannot be restored. So now what I'm doing is I'm using a geometry, left click, drag and put in the workspace. So we can put like this by giving the geometry like this. So again I'm deleting this because I have already one. So in geometry, click there, right click, again you can see new discovery geometry, space claim, and new designer modeler. We are using designer modeler. Why? Because in space claim and discovery it is quite difficult. Once you are comfortable with that means you can use that one. But for basic things and all, we can go with designer modeler geometry only. So click that one, the tab will get open. But here, thing is like for answers, whenever you are doing some simulations, you have to wait. You should be very patient in doing that. So here we can see the different planes and the axis systems. So here XY plane, ZX plane, YZ plane. But most commonly, if you are doing in XY plane, easily you can do answers. It will ask like suppose you are doing a flow analysis means for flow analysis, in which direction the flow should be. That can be easily specified if you are drawing your geometry everything in XY plane. So what you have to do means initially in XY plane, right click and give look at. So the plane is created, and you can draw anything in this plane, XY plane. So here we have in designer modeler alone, we have file, create, so many options, create, concept, tools, units, view and help. In file, either you can import external geometry through this external geometry importing. So or we can open any project, recent imports we can do. So many other things are there that we can easily do here. So that is for file. Then create, in create, just like this one is just like a modeling software. You may you maybe you used CATIA or SolidWorks or Creo for your designing purpose and all. Similar way only. Same options like extrude, revolve, sweep, skin, thin surface, thick surface, everything is there. So you can use any one of the options to design, not any one. According to your preference, you can use the things to design your own geometry file. So today, what we will do means I will teach you one small basic analysis. So in that, what are all the things we will use, that I will tell. So here again we have in concept, line from points is there, lines from sketches is there, 3D curve, split edges, surface from edges, surface from sketches, surface from faces, detach in cross section. So many other things were there. These things we can use for our designing our own geometry. Then in tools, so many see, when you are doing some analysis in ANSYS, before going to meshing, we should be very clear, like we need to clean this geometry. It's like cleaning the geometry means suppose sometimes you will import some geometries, like some files we will import. That time you may design that same thing in SolidWorks or some other softwares. So suppose you are doing that means while bringing here, there will be some discontinuities. There may be some open surfaces. So there may be some other small errors will be there. That can be rectified through this tools. So this whole is like repairing the geometry or cleaning the geometry. We will use this one. Then we have units. So whatever unit you are preferring for your geometry, you can take. Generally, it is in meter or centimeter or millimeter. We can keep. And other things, viewing and all, I will tell when we are doing some thing basic works. I will tell how to do this one. So, and one more most important thing is like here that selection option will be there. So here we have a single select option and box select options, and that selection filters also is there. That selection filters are like it is like this one is like point select or vertex select, then edge select. This one, second one is the edge select, third one is face select, and fourth one is the body select. So by this, our selection process will be like it will be easy for us to do the selection when doing some or designing something in answers. So initially, I have given taken the XY plane, just given look at so that XY plane is shown. So what I'm doing is I'm making one channel. So in that if I want to make a channel and I want to see the how the flow is going inside that one. So here, so for a channel, it's like a pipe only. So in this one is a 2D case. I'm not doing some 3D case. Initially, we will go with the 2D case. So for a 2D case, uh, we know channel means it's like a rectangle only. So I'm selecting here. Here sketching option is there. In sketching option, either you can choose rectangle or else you can draw lines through this one. So I'm choosing rectangle here. So the rectangle, I'm drawing the rectangle here. Now here dimension is there. In dimension, you can give the dimensions of the body. So dimension is 51 meter. So I'm giving like 100 meter. Here again 10 meter. Just I'm giving 10 meter with 100, 10 cross 100. So for this dimension, I want to see whether the how the flow is inside that one. So to do this one, if I want to have any cylinder or circle means inside I can draw another one circle here. So right now I'm not doing that. Just away I'm giving, I'm showing how to make a channel and how to make a flow inside this one. And as I told earlier itself, computer will recognize or answers will recognize the if the boundary is specified for particular geometry. If there is no boundary, it will not select, it will automatically select some, because the answers are already it is evolved. So like previously it will not select anything, but now it is totally evolved. So it knows certain things, it will select accordingly to its preferences, like according to its programming, it will select which is the inlet, which is the outlet, what type of analysis we are doing. So now we should specify where the flow, whether it is an external flow or an internal flow, that we need to specify first. So I told like I want to see or know how the either it is a water or air is flowing inside a channel or a pipe. So for a pipe, for a 2D case, it will be like looks like a rectangle only. So it's a rectangle. I drawn a rectangle. Now the next thing what I have to do means I need to give this rectangle like make a surface so that it will answers will recognize this will be an internal flow, because flow inside a pipe is an internal flow, it is not an external flow. So to do that, what I have to do means concept. In concept, there are so many options, lines from points, lines from sketches, lines from edges, 3D curve, split edges, surface from edges, surface from sketches. So this one is a sketch. So what I have to do means here easily what we can do means select the, because I'm drawing everything in the XY plane, select the sketch, apply, give apply. And in answers, one more important thing is like whatever you are doing, after doing that, we have to give generate. Okay. So to give, I selected the sketch and in operation, see, basic object is sketch that I selected through selecting the XY plane. In that only I drawn. So I selected the sketch, give apply here. So that automatically the sketch is selected. Then operation, two options are there. One is frozen and another one is material. We can add material. So material is added. That's all. And here thickness is not there since it is a surface. So thickness not required. Then give generate. So surface is created. I gave generate. If the generate is not given, surface will not be created. Okay. So surface is created. And next thing is like here we are not going to do any modifications. Suppose I want to do make one more circle here or a rectangle here, means inside I need to draw the rectangle or circle, and I need to give boolean. There is one option called boolean. Now there is no two different objects, so two different sketches not there, so no need of that. But if you want to do anything means we can do through boolean. Then here one more thing is like there is an option called move, translate, rotate, mirror. These things are common in all this modeling software. So no need to worry about this. But still we have so many options here. Just like some other designing modeling software, here also similar options are there. So now I created this geometry and I created the surface. So what will be the next thing to do? Any guys, any idea? Okay, fine.
Just go ahead. If they have any doubt, they will ask.
Okay, okay, fine. So now once that is created, we should give namings. Come, answers need to know where is the inlet, where is the outlet, which one is the wall, and that we need to know. So we know for a pipe there will be an inlet and there will be an outlet. Then only will be we can have some flow inside that. So I want to make inlet and outlet. So what I'm doing is selection filter. I am just selecting the, see now it is in face select. Face select means suppose I am selecting means the face only will get selected. So if I am giving point select means you can see here only the point will get selected. Here if I am giving this point will get selected. Only the points will get selected. So now I need to make this region as an inlet and the other side will be the my outlet. So this inlet region, I'm just selecting the edge select and giving selecting the left hand side and right click there. So you can see the named selection. In named selection, just type here inlet. After selecting that, after typing the name, what you have to do means give generate. Then only the name will be generated. So now if I am selecting inlet, automatically that region will be highlighted in the form of a green line. Now inlet, which region is the inlet that I have given. So now next thing is to know the outlet region. So outlet I am selecting again. The other side I'm making that as an outlet. So again named selection, right click, named selection in that outlet. Then again we have to give generate. Then remaining we have two more edges. That region that will be the wall of the pipe. So I am selecting that by giving control, or else you can do like this also. Named selection you can apply. If I want one more, you can. So sometimes that. Okay, by control only you can select. Sometimes for somewhere it will show like one plus symbol will be shown. If it is shown means you can directly select that one. So two edges were selected in named selection. I want to give that as wall. So I'm giving wall. Then give generate. So now we have this things are the namings or the boundaries. Okay, this inside this boundary only our flow analysis will takes place. Okay, so we have a inlet, outlet, and wall condition. Now designing is over. Because I'm only seeing how the flow is going inside this channel or in the pipe. Okay, so once it is finished means give once again generator and close. So your geometry is ready. Now next phase is to do the meshing. Here you can see component systems mesh one tool is there. Left click, drag the tool and put in the geometry. Left click again, see I will repeat it once again. Left click on the meshing, drag and put in geometry. Okay, now double click on geometry, sorry, meshing. See here, same way. First thing, click on mesh. So many options were there. We will learn one by one when doing the analysis only. Because if I'm keep on explaining the all tools means it will take so much time. So whenever we are doing analysis, I will tell what is necessary that we will learn. Other things you will learn one by one. Okay. So in physics preference, here we have to give which type of analysis is ours. So ours is a CFD analysis because a flow analysis. So I'm selecting CFD. And one more thing here, when doing the analysis, we should be very clear with the length of the model, height of the model, this things and all we should keep in mind, or else just note it down. So I think I gave 100 meter here. So if I want to mesh this geometry, I need to know I should give some sizings. Then only it will do the mesh. So right now for this, either you can go with this. So here also, right click on mesh. You can see insert there. Sizing is there. Or method is there. Then contact sizing, refinement, phase meshing, mesh copy, then match control. Different types were there. Okay. So if I want to do like very generally, if I want to do means you can go with the face meshing. In face meshing, select the face, apply here quadrilaterals. Then in mesh, you can give some sizings. How much meter your how much element size we need to have. If I want to change that to mm means you can change here to mm. You can give like 10 mm or 50 mm. Suppose I'm giving 100 mm means you can see here, give generator. This is basic one. Okay. So mesh is created in 100 mm. So if I want to increase that, and you can see here a structured mesh, because here it is easy. Suppose you have a complex face means you need to split accordingly. The face split the faces accordingly so that we can create a structured mesh in here in this geometry only. Okay, so here either you can do like this, right click insert face meshing, you can do like this, but so many different methods were there. I will show one more. See here, again insert, you can go with sizing also. Sizing means again you have to select edge, select here this both sides, we can both edges we can select, apply in and the type is there. Definition, scoping method is geometry selection, and geometry you need to select the edges which you want to mesh. And see, I will do two sizings here. One is this edge, that means a inlet and outlet of same length. So I will do sizing for inlet and outlet together. And the walls, that is also of same length, so that I will do the meshing for the walls together. So now initially when I'm if I want to give the sizing for this one element size, it will ask like type. It is asking in that so many different types were there: element size, number of divisions, factor of global size, sphere of influence. That depends for different type of measures. Now we can give number of divisions. In number of divisions, it will ask like this edge should be divided into how many number of divisions. So if I give this one into 100 means this will be divided into 100. If I want to give 50 means you can give 50. And so what this will be divided into 100. Next one is this one. So select both things, insert sizing. Again, you can give sizing, or else in mesh also right click and same thing, it will be revealed. Same again in type, definition type, you can give the number of divisions. In number of divisions, this if I want to divide by 500 means it will be divided by 500. If I want to divide by 1000 means 1000 divisions it will have. Then now itself you can give, suppose for a complex geometry means again you have to give face meshing and select the face, apply, give generate. Now click on mesh, you can see how many number of divisions it is getting meshed. Okay. See here, one more is there, biasing is there, that now not required for an for airfoil, doing some analysis for airfoil, or doing some analysis for some external flow analysis means near to the surfaces. Suppose uh, you know, near the surface only we need to know about no, we should get the correct results or accurate results. So that region alone we need to mesh finely. So what we'll do, we will use biasing, so that in biasing we can get some fine meshes near to the surface. But for this geometry it is not required. So again you can see here, we have inlet, outlet, wall. If you are not giving namings in the previous, that means in the geometry, you can give your namings in mesh. After meshing, we cannot give anything, because here up to this much our pre-processing will be over. So now our pre-processing is over. You can see here mesh. If you want to increase the refinement level, means we can increase. Otherwise, this much is enough. So now for us, this much is enough. So what I'm doing, giving one generator, close. Now mesh is finished. Once mesh is finished, next is to go for fluent. So again left click, drag and put the fluent in meshing. Okay, then see here, the tick mark is changed. Last class itself I discussed with you the same thing. If there is no tick mark, then you can ensure like there is some mistake or something to be done for finishing the part. So here the part is meshing is finished, but that should be transferred to fluent. To transfer that, we need to give update. So what I'm giving is right click on mesh, give update. So mesh is finished. So once mesh is finished, you can see here the green tick. So green tick is for means select the fluent. In fluent, you have to give double precision, and this one is like how many cores you have to select. 4 cores. That is if 4 cores, if you are selecting one core means in only one core the whole process will be done. Better is to, like for an i5 or i7 processor, better is to select 4 cores. For i7 and all we can go for up to 6. For i3 we can go with 1 or 2. That much is more than enough. But for i5, i7 and all we can go with 4 cores. So you can see here, in the geometry, blue lines indicate that is the inlet, and red line indicates, red arrows indicates that is the outlet. Now this is the setup for we should give initial settings to do the analysis. So there is an option called see, this is most important thing. If your analysis is a transient analysis, you should select transient. But our case is a steady state analysis, so we can select steady. And a type, if for a normal like low speed flows, we can go with the pressure based. But like if compressibility is coming, means we can go with the density based analysis. Okay, then velocity formulations, no problem. But in the 2D space, again, for a 2D analysis we can go with the planar. But for sometimes some cases and all, like for an aircraft, most probably what we will do, like one side, for some analysis and all, like half we will do symmetric. Some analysis, both some region, like what to say, half will be like water analysis, water will be flowing, half air will be flowing, like that some analysis. That time and all we should go with axisymmetric types and all. So next is a models. So many things were there. multi-phase analysis. I told now only I gave one example for multi-phase analysis. Then like regular term laminar inviscid flow, like spalotalamus, so many things were there. And one good thing in answers is like defaultly it will give some values. But if you are going with some open form or like SU2, like so many other things were there. There we only need to specify what to be done, what to be done. Here almost for a general case, almost everything will be there. Only thing we need to choose one or two things here, so that we will get some for a particular what we require. Accordingly we will get the things. So energy will be on. For our analysis what I'm doing is one gen that also not required now, but normally for an analysis, if temperature factor and all if you are giving, means automatically energy should be on. So here k omega or laminar, now we will go with the laminar case, one small analysis. Then next thing is after selecting this, next is to select the material, because this one is a fluid flow analysis. So definitely it should be air or some other things. Suppose it is a flow of air, means you can see here. So here density, incompressible, ideal gas, everything is there. So let us give ideal gas only. In viscosity, Sutherland, that is a standard thing we will choose for doing some analysis and all. And next is to give the boundary condition. So boundary condition for now what I'm doing is just I'm giving some 20 meter per second or 10 meter per second inside of air flowing inside this pipe. So 20 I'm giving. So 20 apply. If you want to change the temperature, means you can change some like uh, 300 I am changing to 295, simply for your understanding purpose I am changing. And here internal, no need to change anything. Outlet you have to check whether it is a pressure outlet, because here it is like inlet is a velocity inlet, and here this will be the pressure outlet. And other things, wall, we should check the type is wall only, it is specified or not. How we can check means click, left click on wall, then again right click, type, you can see there that tick mark will be given. In the tick mark you can see what type of boundary is given for this one. So this two, both sides, upper and lower side will be the wall, and left hand and right hand side will be the your inlet and outlet. So that I have selected. So once that is done, then straight away, because dynamic, then so many other things were there, that and all not required for this type of analysis. So now compute from inlet, from a reference value from where it need to be started, from inlet and to the zone where it should, the analysis to be carried out, means it is a surface body. So I'm selecting that. Then uh, if you want to know the force and drag of some body, means like lift and drag of some body, means that here it is not there. Suppose I am having some cylinder, means then report plots we need to, in monitors report plots we need to check, otherwise it is not required. And this methods, you can go with symbol only. And this second order and all, right now it is not required. It will defaultly select, but for your some conditions, suppose you are doing some project work about a particular conditions, mean then we need to carefully select this one. Each will be like suppose now for normal things and all, pressure will be like a standard we will select. But for some conditions, like there will be a pressure increase in pressure gradients, means too much fluctuation in pressure gradients, means we need to go with presto. If medium like, means then we should go with the second order, like that. So many things were there. Right now if I am telling, means that you will not understand. One by one, for our work, for when you are doing your work, we can start doing that. Okay, then straight away we can go with the initialization. So here we have hybrid and standard initialization. Now we specified the inlet, so no need to worry about that. We can straight away give compute from standard initialization, their compute from inlet and give initialize. And after giving initialization, just wait for 2-3 seconds so that initialization is done. Sometimes that if you are changing after giving initialization, don't change anything. Suppose if I am changing some parameters in the settings, means again uh, you have to change everything. Okay, again you have to give initialization. Then one more thing, when suppose you are doing some meshing, means meshing, and again you are opening geometry, again you are opening fluent, means error will come. So better to close any suppose you are going for fluent, means close other things and go only for fluent. So now initialization is done. We can run the calculations. I'm giving like 1,000 iterations. Just give calculator. So here nothing is there. The symbol analysis. So solution will be converged because I am not giving anything. If I have put something here, means automatically for that the process will be done. Here nothing is done. So this is how we have to do one analysis. And after that you can see the contours through this one also. See how the flow will be. This is how the flow is. But in Fluent, the graphical interface is not that much good. So better is to close this one and start drag and put your results. So I'm giving the results now. So here symmetry, double click on symmetry. In this one mode, you have to change to variable, and in that smooth give banded. You can see this things here. Okay, can change to velocity and check. So actually here nothing is there, only the flow, no variable will. That means throughout it is having a maximum velocity. You can see here 20 meter per second throughout, no change. If there is no slip condition, anything is as that means the any shear stress is given, means then it will behave accordingly. Since it is taken as I gave the boundary condition as wall, so it will consider that as a no slip conditions, and therefore throughout the pipe the flow will be like with the maximum velocity which is given. Okay, so like this only we should start do one analysis. This one is a very basic small analysis. Okay, so now if I want to see the streamline, means you can see the streamlines. See the flow streamlines. These are the streamlines. Like this is so many things we can do right now. This one is a basic how to process in a fluent or a workbench. That only we did. So many other things were there that we will learn one by one. So for today this much is enough. If you have any doubt, means you can ask now.
Student, you have any question? Please ask.
My one suggestion is like just to practice these things, because I may go a little faster or not, I don't know how. Based upon your reply only, feedback only, I will come to know. So you practice it. If you are familiar with the interface means and what are the steps to be followed, then it is easy to do start with something.
Yeah. Jenny, I have one help from your side.
Uh,
Can you just share that any link that how to download or any kind of textbook you have to refer these answers?
okay, ma'am. That I will share.
You
Actually,
share with me.
textbook is not there.
Textbook is not there, right?
Uh,
Website is there, right? In the website, something is there, right?
websites we will get, ma'am. Actually, like if we will start one or two problems.
Hmm.
Like I will give some problems. They can solve. I will give some insights, ma'am. Some links and
Yeah,
all I will
what we
provide.
can do, Ginny, that already we have almost got some certain, as it is a research based.
Yes.
So I got some basic background that which on which sector they want to work on.
Okay,
There are
ma'am.
some students who want to work on fuselage and
Hmm.
rocket, glider, VTOL.
Uh,
So can you give me some insight about it? Like VTOL, can we do it in a very as a very fresher?
everything we can do, ma'am. But thing is like initially they need to learn 3D analysis. After
Okay.
knowing that only they can start with that one.
We told,
Suppose
right?
yes, VTOL and all. Just first 3D, because
Yeah.
VTOL even after designing itself, it will take so much some difficulties we will face for cleaning the geometry. Once the geometry is perfectly cleaned, we can do analysis here easily.
Hmm. So
Thing is
the
like
beginning itself it will get stuck. Like we it won't get cleaned properly, so it
yes.
will not generate surface.
Yes. So one by one, if they are starting means easily, and easily they can do. Thing is like
Okay.
if they are going with for some 3D analysis for an entire aircraft or entire UAV means before that, my suggestion is to start with a regular rectangular wing initially.
Hmm.
So
Hmm.
once rectangular wing, if they are very clear with that means, then they can go for first airfoil they need to do, then rectangular wing. Once
Hmm.
2D case they are very clear, 3D case
Hmm.
they can start. Then once that is ready means, only thing they need to import their file, just clean that one and start doing the analysis. But after that, for as you told, like a research point of view means, after
Hmm.
that, like we will give some inputs like how to get the accurate results. Initially, they need to
Right.
know how
Right.
to take results
Hmm.
with the geometry.
Okay.
That's all.
Right, right. So I think meanwhile they will work out on that area. So
Hmm.
I think then we too will in this in we have the time constraint is there. I think
Yes.
better to go with a single part. If it is maybe the frame part, they can go, or
Hmm.
the propeller, they can go for it. I think. Do you suggest for that?
Propeller also they can go, ma'am. But propeller is a
Propeller
complex
would.
thing. We should go with the
Okay.
transient analysis only. I
Okay.
don't
Right.
know their systems and all. I don't know whether that is capable or not.
Right. Right. Yeah.
But two three ways we can do, ma'am.
Yeah.
As you told for research,
Mm-hmm.
even suppose for a propeller, for an example, I'm telling for a propeller
Mm-hmm.
means propeller at one like it will show give because it is rotating only. But
Right.
we if we want to rotate the same thing in answers means we should go with some complex analysis here. So
Mm-hmm.
initial stage, what they can do means statically we will keep the propeller at different rotation angles,
Mm-hmm.
and we can check how the flow is. With different rotations, we can check like at different angles like 0 degree, 15 degree, 30 degree, like that up to 360 degree. We will check. We can check that one like that. That one will be the initial part. They will get some idea. Once that is done, then they can go for the transient analysis. Their propeller itself it will rotate, and we can start doing the analysis.
Okay, okay, okay. We can create a team, so
Hmm.
we can gradually we can give one exercise to one of them,
Yes,
right?
yes. According to their project work, what you are giving, accordingly, I will.
Yeah. So before
Hold on.
fixing it, so I thought of create an open discussion so student
Yes,
will also know their challenges because
yes,
already I knew this thing will come up because it's going to be a very complex thing.
Mm.
And okay, now there are few students want to do a nozzle part. I think nozzle using asymmetric we can do it, right?
Yes.
Yeah.
Yes, ma'am.
So
That is
nozzle, I
easy
think,
only.
yeah,
Nozzle is easy only, ma'am. No problem.
yeah. Nozzle is easier. So
Yes.
maybe in next class you just show how to import airfoil and do it. So
Mm.
it will be, I think, gradually it will be easy for them, right? Uh,
Okay, ma'am.
and meanwhile they will practice it, right?
Ah,
And
okay.
this session is getting recorded, so it will get uploaded in a couple of hours. So I will share with the students so they can, follow up with the lecture.
Mm. Okay, ma'am. Okay.
Right, right, right.
Thank
Thank you so much. I hope students are not having any. Actually, there is some question. Chat box.
Now, this one is also some aerodynamic analysis only. Don't worry. Next class, I will teach you how to get the aerodynamic results from this one. Not this one, some objects.
See,
Whatever. Yes, like an
in
air.
this point, yeah, in this point, I would like to say something. Aerodynamic means doesn't mean only the flow, how it is moving. It also matters with the pressure, velocity,
Yes.
temperature, what is the nature of the flow. So when Dr. Jini was putting the boundary condition, he said that transient and steady part, right? So you must understand what is a mathematical model that is you're going to that you're implementing in this problem statement, right? So you must understand here also aerodynamics are involved, right? So please, if you have your basics are not clear, so please brush it up in the next class when you're coming, right? Yeah. Okay. So any other question you have? So please, next class, Ginny, you would like to give an exercise for the student, like for their practice?
No, right now, if like this only they can practice, ma'am. They
Great.
will know how to import everything or how to make a geometry, create some geometries. If possible, ask them to make one same pipe inside a pipe, one circle or a square.
Okay.
So that next class I will teach them how the flow over a square or a circle or whatever designs they are keeping.
Mm-hmm. Okay, great. So I hope students have got the information that this is your task is to practice this particular exercise to get hands on this particular software, right?
Yes.
So if you have any questions, you can just let us know in the next class, right? And our team will forward you this recorded video, right? Okay. Thank you, Dr. Jeannie. Thank
Thank
you.
you. Thank you.
Okay, good night, everyone. So, see you in the next class.